Hey guys, it's Joe again. I'm going to go over a little bit of a KVL problem here. This is a question out of the book that I've kind of modified. It's actually supposed to be going for wide delta transforms, which has to do with resistances. However, I'm going to show you how to do a KCL problem to find what the voltage at A is and the voltage at B is using KCL. So that being said, let's go ahead and get started. Um, I don't like the way that this is drawn. I think that it can be drawn easier for a human to understand. Basically, this is a ground node here, and it shares a ground. It's all ground. And then this node up here is also the same. Basically, everyone shares this node, and if you can tell, this is where 120 volts is. So we can actually redraw this as something like this, where we have 120 volts here, a resistance of 12.5 ohms, another resistance of 5 ohms, and then we have another resistance here of 10 ohms, but this is also 120 volts. Now basically we have a 20 ohm resistor and a 15 ohm resistor that is tied to ground. And then we have a completely separate circuit, basically, of 120 volts that is in 30 ohms that is tied to ground. So basically, we really don't need to find, in order to find these two, VA and VB, we really don't need this circuit here. Now if we use that circuit, we can use it as, like, if we want to find out what the input current is, then we can figure that out. But basically we already know what the current is because it's 120 volts minus 0 over 30 is what the current through, we'll call this one I, 30 ohm. Alright, so with that being said, let's go ahead and get started. We have VA and we have VB. We'll do VA in yellow. So we'll start off with the equation 1, and we have 120 minus VA. Oops, sorry. In this one, I always, basically when I always choose a VA, like in this, I always say that the currents always go away from it, just so I can add everything. If we get a negative number, obviously it's different. So let's go ahead and get started. VA minus 120 over 12.5 plus VA minus 0 over 15 plus VA over 5, VA minus VB over 5 is equal to 0. Okay, and then the second equation will be really similar. So we have equation 2, and we'll say that one is VB minus 120 over 10 plus VB minus 0 over 20 plus VB minus VA over 5 is equal to 0. And that's the two equations. So basically all we have to do is plug and chug, solve for one, and basically use mathematics in order to solve for the other. So we'll start with the first one. We can factor out VA. So basically we have 1 over 12.5 plus 1 over 15 plus 1 over 5. And then we can move the 120 over 12.5 to the right and the VB over 5 to the right. So you got 120 over 12.5 plus VB over 5. Now basically if we multiply, if we get a common denominator, we can go ahead and multiply. I'm not going to really do that, just use your calculator when it comes into random numbers, but we got 1 over 12.5 plus 1 over 15 plus 1 divided by 5. That comes out to 26/75. So VA 26 over 75 is equal to, and then we can basically leave this alone, or we can multiply both sides. So 120 over 12.5 plus VB over 5. So basically if we multiply the right hand side of the equation by 26/75. We got 75, so 120 divided by 12.5 times 75 is 720. So you get 720 here plus V 75 divided by 5 is 15, so 15 VB. And then we have to divide these by 26 each, and that's what VA equals. Alright, so basically with that, we just take this and simplify it as well. In terms of VA, we'll leave VA to the right, so we have let me write this in orange, VB, and then we'll factor out 1/10 plus 1/20 plus 1/5, and then we got minus some sort of VA over 5, so minus 1/5 times VA, which is 720 over 26 plus 15 VB over 26. And then we have to say this is equal to 120 over 10, or just 12. Okay, so basically what we get on this number here is VB, so we got 1/10 plus 1/20 plus 1/5 is 7/20. So we got VB times 7/20, and then minus this stuff over here, and we said that was equal to 15 VB over 26. So 15 divided by 26 and multiply that by 1/5 is 326. So minus 326 VB is equal to, and then we'll move this stuff to the right hand side, so 720 divided by 26 is 360/13, and we'll divide that by 5, and we got 72/13. So basically, I lost my page here. So 72 over 13 is that number, and then plus 12. Basically we have VB, so 7/20 minus 326 is equal to 61/260. Is equal to, and then 72 divided by 13 plus 12 is equal to 228/13. And then if we multiply that by 260, you get 4560, and if you divide that by 61, you get 74.75 volts. So VB is equal to 74.75 volts. So it's good because it's less than 120 volts. So that could be right. So VB is 74.75. Let's go ahead and say VA is equal to 720 over 26 plus 15 times 74.75, and then we're going to divide that by 26. So that comes out to 70.817, so about 70.82. Now, is that right? Let's double check. Let's go into LT Spice. And what I'll do is flip my laptop around here, create a new file, and what we'll do is say that we have a source, so we have a voltage source here of 120 volts. We got some resistors, one here, one here, one here, and one here. We also got 30 ohm resistor just to show it doesn't really matter. Then we'll tie them all together. here. And then there's one more resistor that goes across this point. And we have to finish the wire here. Okay, so right click, it's 120 volts here. This resistor is 12.5 ohms. This resistor is 10 ohms. This resistor is 5 ohms. This resistor was 15 ohms. And this resistor here was 20 ohms. This resistor is 30 ohms. And then we had a ground on the bottom. So wherever, just right there. So just before you go to simulate and then run, it'll ask you to do the transient, which we're doing. We'll say the step time is just 0.1. Time to start interval is 0.1. Maximum time step is 0.1. Start time cannot be later than the time step. So basically we have to do that 0.01. Oops, opposite I guess. Okay, and it's simulating right now. Basically, like we said before, we should get 70.82 on the left side and 74.75 on the right side. Okay, so yeah, we got 74.75 on the right side, and we got 70.82 on the left side. So VA was 70.82, and VB was 74.75. And if we look at our answers, that's exactly what we got. Alright guys, I want to thank you. I'm running a little over on this video. If you have any questions, please leave comments below.